So if we're taking the derivative of a function divided by a function, if one's just a number, you don't have to do the quotient rule. We did something like that, like x squared over 3. That's just like a 1/3 in front. You can ignore that, and we'll kind of talk about that in a minute. But the top is very similar to the product rule, except for, I think JD called it yesterday, it's going to be subtraction. You're going to take the derivative of the the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. Order matters here. On the product rule, it doesn't matter in what order you do that in because you're adding, but when you're subtracting, it really does matter. You have to take the derivative of the numerator first, and you're going to divide that by the denominator squared. When we have a test in here, you have to have these rules memorized, right? The AP test, you have to have these rules memorized, so you have to memorize them. So there's lots of ways of memorizing this. I think I never learned a tricky way of memorizing it. I just memorized derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. That's not very exciting, right? Steven, get better soon. That's from Sarah. Remind me to pause this when I sing the song today. I really don't want that. So here's one way of remembering this, okay? If you call the numerator high and the denominator low, because high is on the top, low is on the bottom, right? D means derivative, and so you can say low d high minus high d low. All over the denominator squared we go. Look, that's the words that go with it. That's terrible. Low d high minus high d low. All over the denominator squared we go. As long as you're multiplying, it doesn't make the song very nice, right? D means derivative, right?
Yeah, well, why is it low? I thought it was F squared.
It is. I'm just trying to make a little cute song about it.
Did you make the 7, 6, 7?
I stole it from you, too.
But you're not singing it.
Well, I'm not singing it right now. I'm showing you this.
Are you going to sing later?
There's one here about this. I'll show you this one. It's if you call the numerator high. I'm impatient. High. Oh, man. I just want to punch this. High over ho. Then you can say, ho d high minus high d ho. That's the numerator squared divided by ho ho. That's another one. I have to do that. But you have to do that started. That's not that cute. I always had to think really hard about that one to get that one to work. But then this one, I found this one on YouTube, and I kind of changed the words a little bit to match our school. But here we go. Are you ready for this? Let me pause this. Steven's missing out. I'm not. Oh, terribleness. All right, let's do it.
Can we get that on paper?
Go. I was thinking today, I'm like, I wonder if Mr. Puckett wants me for a walkthrough. I was thinking that would be really clear. Especially the ass part. He might not like that part.
Yeah, I was just like,
Oh my gosh, he's gonna say it.
I did too. I was like,
I was so excited.
ass and toads. Where would math teachers be? We'd have no jokes if we didn't have ass and toads.
I'm really thankful, or not a joke, a dream left that I have on it, so you guys can know.
Okay.
What?
So, here's the thing. When you see problems like this, you got to recognize to use the quotient rule. And that's the part on the test that you have to say, oh, I can't just take the derivative of the top and the bottom. I can't make it a product. I have to do the quotient rule. So to find the derivative, I'm going to take the derivative of the numerator, which would just be 1. X plus 1 would just be 1, right?
Wait a second, I thought we were doing the low. Low d high?
Oh, do you want me to do it in that order? Is it okay if I do the top?
No.
I always just do the derivative of the top times the bottom minus the derivative of the bottom times the top.
So would it be high d low?
I'll do it your way. I just have the song. I don't really use the song.
I don't use this on either, and this is going to be, yeah, like, what you're at. Go ahead, do high.
Don't you agree that you can multiply in any way that you want? Like, we really should be okay. Whether I write 1 times the square root of x or I write the square root of x times 1, you should still be able to look at that and realize where that's coming from. I'm taking the bottom times the derivative of the top, or I'm taking the derivative of the top times the bottom. Multiplication, it can happen any way, either way, right? I'll write it both ways. So you write the way you want to do it. Minus the derivative of the denominator, or low, times the numerator. This is the same as x to the 1/2 power, right? So it's bring down the 1/2. X, subtract 1 from 1/2, and you're going to get negative 1/2, right? We got to be able to deal with fractions when we're taking derivatives. They're going to be a big part of it. Times the top, which is x plus 1. Or, if you go the other way, that would be x plus 1 times 1/2 x to the negative 1. And again, we should be okay in whichever order we go in. All divided by the denominator squared, which is going to be the square root of x squared. So step 1 is you got to learn that formula and be able to use it. The next step is algebra, and that's the step that we tend to struggle with a little bit, is you got to be able to simplify this and simplify it enough that it matches the answer that would be on the multiple choice or the answer in the back of the book. When I look at the top of this, I see two things. I see one has a square root of x and one has an x to the negative 1/2. We either need to decide, let's use all square roots or let's use all fractional exponents so that we can kind of match that up. So what would you rather do? You want to use square roots? If I deal with this as a square root, that's going to be in the bottom, so that's going to be like 1 over 2 square root of x times x plus 1. Yeah, I think I like exponents better because you can just add the exponents or whatever you need to do with the exponents. But I'll show you, we can do it this way, and then we can do the exponents too if you want.
Wait, so is that 2 square root of x like this in the bottom?
This 2 is in the bottom. This negative means the x to the square root of x is in the bottom. Negative exponent means it's in the bottom of the fraction.
Is it still like all over the square root of x squared, or is it beside it?
All over the square root of x squared, which is just x, right? The problem with doing this with square roots is I think we're going to end up having to get like a common denominator here. It would work. Because couldn't I just put this on top of this? Do you agree with that? I'm going to rewrite that. So I have the square root of x minus x plus 1 over 2 square root of x all over x. We talked about this when we were doing limits. Anytime you have addition and subtraction, like a fraction and a fraction with addition and subtraction, there's a lot of rhyming there, you should probably get a common denominator in hopes that you could cancel something out, which this isn't terrible to do. Do you agree I just need to multiply this by 2 square root of x? We could distribute, but then we're just going to have double terms here. Like we could distribute. You're not going to get the wrong answer if you distribute, but you can just multiply top times top, bottom times bottom. Yeah, so if we take 2 square root of x on the top and the bottom here, you're right, Sarah. Square root of x times the square root of x is just x. Make this go up a little bit. So on the top, I have 2x minus x minus 1, distributing my negative, all over 2 square root of x, all over x. What can I do now? Yeah, definitely, once we get one fraction over one fraction, we can flip that up and multiply by the reciprocal. Also, maybe you can see that 2x minus x is just x, so I'm going to kind of simplify that all at once, maybe. So on the top, I'm really just going to have x minus 1 over 2 square root of x times the reciprocal of this, which is 1 over x. No, nothing does cancel out, but it does make it a simplified fraction. What do we get? X minus 1 over 2x squared of x. Just want to throw this out here that if the book kept it as fractional exponents instead of square roots, they could have also had an answer of, what's the exponent on this square root? So if I have x to the first times x to the 1/2, what do you do with those exponents? You add them and you get x to the 3/2. Those are the same answers. You gotta be comfortable using both. We will do this stuff a lot. We'll have a lot of algebra. We'll have a lot of what I call some crazy factoring. This is the first one we've done, and so they're not all this bad. But either one of these answers would be okay. How do you know you're finished with the problem? Well, if it's odd, definitely check in the back of the book. But you should never leave a fraction in a fraction when you're doing these problems. Like, you should always try to simplify that, which is where quotient rule can get a little bit messy. Let's do another one. After I teach the quotient rule, many people, anytime they see a division sign, a fraction bar, they automatically jump in and do the quotient rule. And you can do that. Like on this problem, y equals 3x squared minus 5 all divided by 7. You can do the quotient rule and it's going to work out. It's actually going to work out not bad at all, because what would the derivative of the denominator be on this one? 0, and so you actually are going to get one whole thing to cancel out. But part of your homework today says rewrite before differentiating, which means they're telling you you don't have to do the quotient rule. If the top or the bottom, well, maybe not the bottom, the top. But if the bottom is just a number, could I write this as 3 over 7x squared minus 5 over 7? Or you put the x squared on top if you prefer. Or you could pull 1/7 out front, like that's the same thing. I call that undoing a common denominator. Do you have to do the quotient rule if it's written like this? No, I could have given you that on the first day, on Friday last week, when we just learned the power rule. And so just notice that you don't always have to do the quotient rule, and so you might save yourself some time on some of these problems. You're not going to get the wrong answer when you do the quotient rule, but I definitely think this would be a faster way. So now when I find the derivative, again, notice when you find the derivative, you need to show that either by saying dy over dx, or y prime, or f prime of x. And what would I get as the derivative of 3/7 x squared? I'll just show something here. What's the derivative of x squared? 2x. And remember the constant multiple rule says if there's a constant in front, you can just kind of ignore that, and then we can multiply it out. And what would be the derivative of negative 5/7? And so we just get, multiply the top times the top, bottom times the bottom, 6x over 7, or 6/7 x. That is the same answer that you would have gotten with the quotient rule, but definitely a lot less messy, not dealing with fractions so much. Last week when we did the power rule, some of you weren't that big of fans of dealing with negative exponents, which means you might prefer to use the quotient rule on this problem. But since the directions say rewrite, I want to rewrite it and show you how we don't have to do the quotient rule. How could I rewrite this so that I could take the derivative? Yeah, definitely to move this x squared out of the bottom, I could just bring it up and make it x to the -2, right? Remember that's the definition of negative exponents, is like the reciprocal or moving it across the fraction bar. What about the 5? Does it come up with it? Not unless you want to make that 5 to the -1. This is just like 4/5, like JD said. So 4/5 x to the -2, and then you can use the power rule just like we did before. Again, the quotient rule is going to get you the right answer, but you're probably going to get mad if you do the quotient rule and then you realize you didn't have to. So again, remember with the negatives, you got to think about you're subtracting one from the exponent, not adding. So if I bring down the -2 and I subtract 1 from this, what's my new exponent? -3. And let's write it back so that we don't have a negative exponent. 4 times negative 2 is negative 8. And move that x to negative 3 back to the bottom, so you get negative 8 over 5x cubed. Because you're subtracting 1 from this, right? Isn't the power rule bring that down and you subtract 1, not add 1? So when you're dealing with negative numbers and you subtract 1, it's just going to become more negative. Watch those negatives. That's why I said some people, I think Caitlin was saying she wasn't a big fan of the negative exponents when we did it last week. Do the quotient rule. The derivative of the top is going to be 0 times the bottom, and you'll still get the same answer. You just might have a little more simplifying to do. Questions about that? Let's see what else I got. Oh my goodness, look at this big one. I'll give you a minute to write this down. What? Okay. Here. What's some hard ones on your homework? What if there's a problem where there's like a product and quotient rule in the same problem? There's some problems in your homework like this, and I think these are some good problems to see if you can do the product and the quotient rule. It's just a lot of writing to put in your notes. Again, it's a lot of notation that we seem to be struggling with knowing what u of 2 would mean, u prime of 2. And so they tell us that u and v are functions of x, and that they're both differentiable at x equals 2. And then they give us a bunch of values here. What does this mean? U of 2 equals 3. When you plug 2 into the equation, you get 3. That's the y value. What does u prime of 2 equal negative 4 mean? The derivative at x equals 2 is negative 4. That means the slope is negative 4 if we were talking about slope here. And then they just do the same thing for v and v prime. V is just a different function than u. This is the actual value at 2. The y value is 1. This is the derivative at 2. This is not a y value. That's the derivative, which would be the slope there. So it's really important that you know that notation. So we can do the derivatives of u times v without actually knowing what the functions are because they give us the value. So let's just practice with if I take the derivative of u times v, I need to use the product rule, right? What would the product rule say? Don't plug any numbers here. Just tell me what the product rule says. How do I take the derivative of a function u times a function v? The derivative of u times v right? That's just generic product rule. They tell us to find it exactly at 2. So just go through and plug in 2 next to all these. Like I could say u prime of 2 times v of 2 plus v prime of 2 times u of 2. And I think you have all those values. You're just going to be plugging in numbers now from what they give you in the problem. But it's just recognizing that you don't actually need a function. This is a good, another good AP type problem where a lot of times they don't give you an equation, they just give you some values and expect that you know how to work with them. So now it's just pulling out the right values. What is the derivative of u at 2? Negative 4. And what is the value of v at 2? 1. Plus the derivative of v at 2 is 2. And the value of u at 2 is 3. So it's not really a lot of hard work. It's just kind of recognizing what to do on that. So I think we get negative 4 plus 6. The answer there would just be 2. So see if you can do the quotient one. Set up the quotient rule. You can use 2 using the quotient rule and then plug those values in. Let's see if we can get the right answer. And maybe after you get the answer, write it on your boards and put it up, and I'll tell you if you're right or wrong, since Sarah wanted me to just tell you all if you're right or wrong. Right, like my advice is don't try to plug the numbers straight in. Set it up like I did with the U's and the V's. The derivative of the top times the bottom. Or you can sing the song as Caitlin wants to.
And it'd be over V squared.
Write it on your board and hold up, and I'll show you right or wrong. People, here's our new job before you leave in 6 hours. We have to make sure all these boards are back on the shelves. Otherwise, I have to go around and pick them all up.
Which is very interesting.
And I really can do it, but eventually it's not going to be so easy. Right now, it's really not that bad, but we do nothing in 6 hours. I can the last 20 minutes.
Whatever.
But watch Sarah's slideshow.
That was a good slideshow, but I was doing that. You never know me if I was right or wrong.
That's okay. I said you're right. It's okay to be wrong. That's how you learn. Let's see where what we've done if we make mistakes. So I'm going to take the derivative of the top. So I'm going to just go ahead and plug 2 in. U prime of 2 times the bottom at 2 minus the derivative of the bottom times the top, U of 2, all over the bottom at 2 squared. And then we just need to make sure we pull the right numbers out. So I think we should take -4 times 1 minus the derivative at 2 of v is 2 times, what's up there? 3? I can't see it up there. All divided by v of 2 squared, which would just be 1 squared. So you get -4 minus 6 all over 1, which should turn out to be -10. It's really easy to pull the wrong numbers when you're doing that. But does that make sense for those of you that maybe didn't do it right this time? Hopefully that'll make the ones on the homework easier. I just want to point out on the homework there are some that look really complicated. Like the top is a function times a function divided by whatever's on the bottom. You can make it a really complicated problem, but remember you can also simplify first. So if you see something in the numerator that you could multiply together before you do the quotient rule, that's my advice to do that because it's going to make your life a lot easier. So again, algebra is such a big part of this stuff as we're doing it. Yesterday you were only supposed to do these 4 problems, and so today you need to do the rest of those. I'm going to trust that you can figure out which problems those are. Everything but 13, 15, 16, and 40. Again, I highly, highly recommend checking your odd answers in the back. Don't wait till the end, like as you do an odd problem, check it so that way if you miss it, you don't do the whole homework wrong before you discover what you were doing wrong. That's why those answers are back there, not just copy down. I know, I use lots of paper on it. That's very exciting.
You have two limits of rules in the same one. Which one are you doing?
Well, depends on when you're taking the derivative. Like if you're doing the top with the product, but like I feel like you shouldn't have to. Like which one? Like what could you do on that without having to do the product rule? Like couldn't you multiply the top out first so it's not multiplication? Like so you don't have the product rule? Otherwise, when you take the derivative of the top, you're gonna have the product rule on the top times the bottom minus the derivative of the bottom times the top, which you don't need the product rule. Like you would just have to do the product rule if necessary. that you can ask me questions if you have them. Also, I want to point out that